We're in the Exactrix Flow Lab here, and Stephanie Mason is going to help us do some of the testing of the 2KR. And James has set up this unit specifically for training. This is actually a used system that came out of southern Alberta, from Tabor, Alberta, and it's been through a certified rebuild. This is the 2KC. This is the 2KP taps formulator here, and up above is the 2KR, and that is the blender. And the blender unit allows us to raise and lower the rates of specialized materials such as ammonium chloride or ammoniated zinc, Hydra Hume, materials that are very expensive, and you don't want to place it entirely across the field, and you may want to get site-specific in zones. Another purpose of this blender is to use the material called soy green, and soy green is a material that allows for soybeans to propagate in high pH soils. So the symptom is iron chlorosis, and we're trying to overcome the plant response problems in high pH soils. So this is also available as soy green application. So we have 3 engines here. So as we progress in our testing here, James is going to help with a little bit, and Stephanie will be opening and closing these valves. On the 2KR blender, we have these 3 valves that you see up here, and these are high range and low range valves using a common flow meter, and this is a divide by 10 circuit that you see in front of us with the green plate, and it basically divides the flow by 10 and delivers it out to the center of the frame where the flow divider mixer is located. In this case, the flow divider mixer is located at these manifolds here, and this is the flow divider mixer. This is where it does the mixing, and we might be, in this particular case, we're down mixing materials at 0.06 gallons per minute, which is very, very low. That is in the 10 ounce per minute range. So these valves are for the 2KP. This is the mixer that comes in and mixes it into the 2KP and on out through the manifolds and to the injection point. So that's the number one place where we like to inject on big applicators, is at the center of the frame. So we send it out in a small line. You see this small line here. It's coming from this pump, and it's flowing about 10 ounces per minute in this particular scenario. Goes into the mixer, makes a nice flow split, comes in, and then it controls the system up and down. The pump RPM changes as you control the valves. So go to a third section, 2/3 section, the pump RPM will raise and lower automatically. When we come to a dead stop, this turns off. This line turns off the ball, not with a ball valve, but it just simply turns the pump off, And we have a backflow check here that prevents it from backfeeding into the system. So we're trying to make these systems as simple as possible, easy to service, and of course the big thing is the cell phone. And so we have Exactrix staff here that are able to answer good, reasonable questions very accurately and very quickly. And I think this has been a very key part of our success, is making sure we can support the guys 24/7 over the cell phone. So I don't know, you might have a tough time finding James on Sunday because he goes to a movie, but I'm normally available, and Stephanie's always available in case you need some super high technical support. So the 2KR has its own tach, and you notice it's turning about 54 RPM. And at this very low rate, how can it be turning 54 RPM? Because it has the same pump as the 2KP. Well, we have a ball valve back here, and I'll walk around over here. And this ball valve here sets a baseline flow for the system. And what that does, it brings the system up so it provides about 3 to 4 gallons of flow at 30 to 50 psi back to the tank, and so that elevates the pump up and produces a higher RPM. So we have a baseline flow that we're working with. This keeps the pump turning faster, gets rid of the steady by jerks, allows a more smooth application. So at this point we're going to illustrate how we move in our different flow ranges of the 2KR. And the 2KR actually has 3 flow ranges, using almost always the same common componentry. All we have to do is rehook lines. So if we want to move out of this 10 ounce to 60 ounce range, which we have here, we move into the high range, then we have to change a line up here. Stephanie, those ball valves up there, you might point those out up here. Those first 2 ball valves, these 2 are the low range flow ball valves, and you can turn those on and off. And you notice there's a 3rd ball valve over there. Its handle is closed, and that ball valve is for the high range. So if we turn off the low flow range, we'll turn on the high range. And we're going to illustrate how that's done and provide a little more information on how you can work with different flow ranges using the same flow meter. The key point is that is a divide by 10 function in that flow meter. And so in our progress report here, we're going to raise and lower the flows a little bit. And James, what are we flowing right now? We're in the lowest range, 1 gallon. Let's take her on up to 3 gallon. And keep your eyes on this tachometer. Now the system increased flow 3 times. The 2KC is running, 2KP is running, and the 2KR is running. The flow meter on the 2KR says 2.1 gallons per minute, but you actually have to divide that. This 2.1 gallons per minute needs to be divided by 10. So it's reading actually 0.21 gallons per minute, which is about a quart, which is about 32 ounces. So at the high end, we're about 32 ounces. Okay, we're going to drop the flow rate down to 1/3 of, we're going to drop down to about 1/3 of what we're showing right now. Check the pressure up here on the 2KR, and it says it's about 150 psi. The 2KP is at 80 psi. Going into the manifolds, etc., it's 80 psi on these manifolds. So this pressure coming in here is at 150 psi. So, and then it drops and mixes in the mixer, gets the job done. So let's go to 1/3 the flow. We're going to go from 2.1 down to about 0.5. We dropped it down pretty good. And notice that the pressure has almost gone zero on the 2KR. The 2KP is at about 40 psi. So we got a very low flow going into the mixer here and on out. I wish we had a visual means to show you that, show the mixing, how it's going on here. But this is very important to mix very close to the manifolds so you get good variable rate response. It's very quick, very instantaneous. When you're dealing in 10 ounces or 15 ounces or 60 ounces, man, it's got to be fast because it takes too long to get there otherwise. So this is on a big wide air seeder that would have the mixing capability up on the frame, and the engines might be clear back 50 feet away on the cart itself. So mixing right here. Now there are other options in this system and for mixing, and I don't want to get people too confused right now, but we can also mix at the 2KP pump before and after the pump, and sometimes we do that when we have more of a common product that's going to be held in a separate tank like Hydra Hume. We can actually mix it at the 2KP. It goes through the 2KP and on out the system, and I'll show that to you here pretty quick. Okay, these are the two mixing ports for at the pump location. So if we have a system design where we want to mix at the pump inlet, we can. So we go right here on the 2KP, the 2KR's up here. It's actually the same pump, but we've got it fine-tuned so it can make these deliveries at an elevated baseline. It's coming in here, and it can deliver up to 3.5 gallons a minute into this mixing combination here. And this is part of the pump, so when you set your goals on application, you got to be real careful that you allow for this to be inclusive into the number value per acre, because you're including it in the 2KP application. So if this is nominal at 10 gallons per acre, you're actually going to set it, if this is injecting 3.5 gallons per acre, then you need to set this up to actually apply at 13.5 gallons. Now if we inject after the flow meter, like we do here, then you don't have to do that. And your database will be very accurate on how you're applying these materials. So there are two locations. This is a check valve. You can remove it and place it down here and inject after the flow meter if you so elect. Okay, so once again, to reinforce this, we have two means of mixing, three means of mixing. Right here we show two, and the third location is in the mixer splitter up on the center of the frame, maybe 50 feet away. Okay, now we've moved into the high range mode. In the high range mode, we're going to mix at the mixer out here, so we've installed a larger line, and we can deliver 3.5 gallons a minute through that larger line to the mixer right here. So, but you'll notice that larger line is coming out of that first ball valve. So, Stephanie, would you close the low range system and open up the high range system? Okay, now we're ready for high range flow. Now our flow meter reading in gallons per minute is reading true gallons per minute. We're no longer using the divide by 10 feature. We've taken out the divide by 10, which has an 0.75 return orifice and an 0.35 delivery orifice. So that means that only 1/10 of the flow was actually being delivered in this black line. So we would divide that number and get 0.05. Now, since we've moved into the high flow range, that particular flow meter is reading the gallons per minute, true gallons per minute. We're not doing divide by 10 anymore. Okay, I think that pretty well sums it up on the 2KR. There's a lot of other features that'll be in the technical manual that we'll talk about. This is a powerful tool in getting the job done with new materials, where we want to find out, does oil and neem work? Does oil and mustard work? Can we use ammoniated zinc? Can we use ammonium chloride? Hydrochloric acid, can we shoot that? Will Guardian be a great material for stabilizing nitrogen? DCD, we already know it is. We just have to prove it on your farm. So Guardian is a big part of what this 2KR is about. We prefer not to use carcinogenic materials in our products, so we will be not using any in-serve. We like to keep all of our employees healthy, and as well as our producers, so in-serve is not utilized in our products. I would highly recommend that you contact a Conklin dealer to learn about Guardian. DCD, well proven in Europe, one of the best materials that we can utilize to stabilize nitrogen, along with ammonium thiosulfate, and possibly potassium thiosulfate will get its label too. So very close to having some great discoveries with the 2KR blender, giving the producer the tool to do the research on his farm to find out, do these materials pay? How does it pay? And thank goodness for these controllers from Trimble and Ag Leader and Deere, etc. These controllers allow us to run 3 and 4 products, and of course James has become our in-house expert on controllers, and we know it takes a lot of technical support to get the job done. That's why we always bring your system in and test it in our flow lab to make sure everything is correct, that when you go out and start up your system, if you want to come to Spokane and run it, you can. When you get delivery in Indiana or Ohio or in South Texas, wherever you're at, clear far north in northern Alberta, you know it's been across the flow station, everything's been tested. So I think that'll conclude our testing. Anything more, James? Got to add anything more?
You got it all covered.
Got a lot covered. Stephanie, any points we missed, Stephanie? Okay. All right. Thank you.
What is a formulator or a TAPS formulator? In an acid-base reaction forming crystalline TAPS, the two systems work together to combine the flows of NH3 and ammonium polyphosphate, APP, and ammonium thiosulfate, ATS, to make TAPS. What is a blender? A blender combines non-adjunctive materials or materials that are not storage tank compatible in the flows of the APP, ATS, and is reacted with NH3 in most cases. Why is a 2KR blender necessary, economically speaking? The alternative is much higher cost stimulant, and nutrient materials must be used to store the blend in the tank. The materials may never be compatible more than 10 seconds before sequester or emulsification begins in the storage tank. The materials like Guardian and Hydra Hume can now be injected into the flow of the APP ATS with very little concern of blend settlement. The new materials that can be used are also high in glucosinolate and therefore stabilizing nitrogen in the TAPS and TAP KTS band with organic materials. Many high-value nutrient and stimulant materials that can be utilized with the 2KR blender could never be considered with dry fertilizer materials. The economic power of the 2KR blender drives production costs down and raises yield potential on a site-specific basis. Soybeans may finally get an economical fertilizer recommendation to reduce iron sclerosis. Is NH3 always required? Typically, the acid-base reaction is an industrial process to make sure the chemistry is correct for maximum nutrient uptake in an exclusive pH shift. The critical part of the mixing is the low 1% CV of the NH3 delivery to assure liquid streaming flows in homogeneous blends with instant reaction. The basic reaction is required in all testing carried out by Exactrix engineers. Even soy green materials work better with a small amount of NH3 ammoniating the double chelated iron material. Site-specific applications are now highly economical, with NH3 providing the positive valence NH4 into the blend, which allows a pH shift. The cost of the 2KR blender must be expensive. The cost is about 1/2 of the 2KP taps formulator. The cost is about 1/4 of the 2KM taps formulator with mass flow. Since no additional manifolds, line looms, or injectors are required, the cost is around $13,757. The payback can be as high as $50 per acre more net income and a cost reduction of $10 per acre using ammoniated zinc on eroded soils. The payback for soybean production can be very significant to the point that soybeans can be raised on higher pH soils.